Welcome to day 5. Right now, our user service is isolated, but in a real microservices architecture, services need to talk to each other. Today, we are going to build a product service, and we will make sure our user service talks to it using gRPC. It's going to give us high performance internal communication. Let's start by scaffolding the new service. So open your terminal at the first store root and run the following commands. So I'll start by creating and initializing the product service. I'll say uv init --app. Maybe I should expand this a little bit so that you can see. Then services /product -service and hit enter. So you can see product service has been added. I can show you by looking at this new directory called product service. And then in the PyProject.toml, we have this string services product service added as the member of the current workspace. That's nice. Then I'm going to clear my terminal and maybe just make it a little bit bigger. And then say uv add. So we want to add two important packages to the product service and then to the user service. So what we want to add is a gRPC IO and gRPC IO -tools to the product package. So I'll say --package space, then product -service and hit enter. Okay, that was fast. Then after that, we can now do the same thing for the user service. So I'll simply remove the word product and replace it with user service. So by now you should get familiar with adding packages using UV and creating the directories. Hit enter. Okay, looks like we are also good to go. Let's move on to the next section where we're going to create the contract. Create a new directory called protos at the root. Call it protos, and then I'll create product.proto file. Ensure to do this. Now, in gRPC, we don't write code first. The first thing to do is to write a contract. And then we shall use protocol buffers to define exactly what data we accept and what data we return. So this .proto file is language agnostic, meaning our Python service could easily talk to a JavaScript, a Go, or Rust service using this exact same file. So the first thing to do is to define the version of the proto we're using. We shall say proto 3. Okay, and this is simply a string. Then we shall namespace it by saying package product. Okay, then after that we can now define the service definition and the data structures, and it's actually quite easy, like you're going to see now. Let me go ahead and say the service we want will be called the product service. Okay, then you put curly brackets, go to the next line. Then we define our RPC. So RPC, if you don't know, is simply stands for remote procedure call. So we are simply defining a single remote procedure call method. And this method is going to be called get product. Okay, so I'll say RPC get product. I think you see how easy this can be. And we're going to say, we're going to define get product to accept a product request and return with a product response. So to do that, I am going to define the structure of the product request and the product response. But let me do that first. Let me I'll say the method get product will take or accept a product request from the client, and it will return a product response back to the client. Product response. Okay, so that's good enough. And then we need to define what a product response is and what a product request is. So I'll come here and say message. Okay, then copy this product request will be, so you do this and then you have your curly braces, and then this product request will simply be an ID, okay, but it will be an int 32, meaning a 32-bit integer, and it will be called an ID, and it will be tagged with 1. Okay, so this is not assigning a value 1, but simply when we have our message, okay, encoded in binary format, Protobuf uses these numbers to identify the fields in the binary encoded data. In this case, it is a ID field, which will be identified with 1. So think of 1 as a tag. Then we also need to define the product response too. Go to the next line and say message product response, curly braces, and this will have a 32-bit field ID tagged with 1. Then it will have a string called name tagged with 2, and then it will have a float called price, and this one will be tagged with 3. Okay, as simple as that. So do not be confused. It's very simple. I'll walk through this one more time. On line 1, this simply tells the compiler you are using version 3 of the proto core buffers language. Okay, and after that, we now have the next line, which simply declares a namespace for our project. Okay, and it helps to prevent naming conflicts between different projects. And of course, when we compile this code into a programming language, like you're going to see, ours will be Python, but it could be Java, Go, or Rust. This package name is often used to generate the corresponding modules or packages in that language. Okay, so yeah, make sure that this line, okay, is not empty. Okay, and don't, of course, try to maybe comment it. All right, let's go to the next section where we are now going to generate the Python code. Now we are going to compile this contract into Python code, and we're going to generate the code directly into both service folders so that they speak the same language. So to do that, I will expand this terminal and clear it, and then I'm going to type uv run python -m. So -m means you want to run a particular package, and that package is the gRPC _ tools. Remember, we installed this, and we're going to access the Protobuf compiler, which will be .protoc. Okay, and so this is a compiler specifically bundled for Python. And then after that, I'll say -i, and this simply specifies the directory where it should find the .proto files. In our case, it is the protos directory, what we created this one here. And then after that, space, and say -python _out equals to services. So Python -out simply means you're telling the compiler where to look, okay, and save the generated Python code. Okay, simply tells the compiler where to save the generated Python code. And in this case, I want to save in the services / product service directory. So I'll complete this by saying services / product - service, like so. Then there's another one called minus minus gRPC underscore Python. Okay. I hope I've spelled that correctly. Underscore out will be equals to services / product dash service. Okay, so this one is responsible to tell the compiler where to save the generated code for gRPC services. So I'll explain this one more time. Protoc is responsible for running the protocol buffers compiler specifically bundled for Python. Then minus minus Python out. Okay, this one is responsible for telling the compiler where to save the generated Python code for the data structures. Then after that, the last one here, gRPC Python out, is responsible for telling the compiler where to save the generated Python code for the gRPC services. As simple as that. Then finally, we have the last one, which will be protos / product.proto. I guess you can know what this is all about, okay? But if you haven't yet figured it out, it is simply the actual input file that we are telling the compiler to process, which is this one here. Okay, so I'll hit enter. Okay, it says protos product.proto 31 expected the semicolon. Okay, let's go to it. Yeah, the first bug. Can you see the issue? Giving you some time to think. Okay, but we need actually a semicolon here. I want to look through to make sure I haven't missed out any other semicolon. Okay, I think it looks okay. In case there's any other issue, yeah, the compiler will tell us. So I'll clear the screen, run the same command, and it's done. So I'll expand this again, clear the screen, and then we're going to run the same command, but this time it's going to be for the user service. But I have to edit. Instead of product service, this time I'm going to say user service. Okay, services, user service. Then go back here, change this one to also user service. So I'm just looking at it to make sure I've not made any mistake. Okay, I think this looks okay. If in case of anything, I'll fix. So hit enter. Okay, and it's now okay. So I'll minimize this, close these files. Then if I go to services, okay, product service, okay, look at this, okay, and I just zoom out a little bit. Okay, you see we have, look at this first statement. Okay, it says generated by the gRPC Python protocol compiler plugin. Do not edit. Then we have another one here. Okay, also it says, it mentions the encoding and says generated by the protocol buffer compiler. Do not edit. I'll close that. If I go to the user service and I click this, it also says the same thing. Generated by the gRPC Python protocol compiler plugin. Do not edit. Okay. Then go to this other one. Okay. Yeah. The same message. Okay. So yeah, do not attempt to get very smart. Let's look at the gRPC server. Open product main.py it's time to build the product service. Unlike the user service, this won't be a REST API using FastAPI. It will be a pure gRPC server listening to port 5000. Okay, I think I'll put 5051. So I'll remove all this code. Okay, we don't need it. And then write a few imports. So I'll start by importing. I need to expand this gRPC. Okay. Then we need from concurrent, I need to import, is it futures? Okay. So this is going to help us to avoid delays. Okay. Yeah. And if you know about concurrency, yeah, you'll appreciate this. But it's just to help us create a pool of threads, okay? So that the server can handle multiple requests at the same time without blocking. So next up, I'm going to import product pb2, okay? And then the next one, product pb2 gRPC. And that's what we generated, okay? These two modules. Again, don't edit them. After that, let's now start the implementation. I can reduce the terminal and write a class called the product service. Okay, and this will inherit from product pb2 gRPC dot product servicer. Okay, yeah, I hope many of you know inheritance, but like we've learned that inheritance simply is a way to borrow. Okay. Yeah. So this class, okay, which was generated for us, simply is how gRPC knows that this class is meant to handle requests for the product service. Then after that, we are going to create a method, a Python method, which will match the RPC get product definition from our proto file. Okay, so I'll do it. I'll say define get product. Okay, so you can see it knows exactly what we are looking for, but I'm going to override. Okay, I'm going to override everything here and to override. But before I override, I can just explain to you. Of course, you know what self is. This is the first argument to an instance method. Request is simply the object which contains the data sent by the client. And you can access fields defined in your Protobuf file using the standard dot notation, like you can say request.id. Okay. Then context simply provides RPC specific information like timeouts, metadata like headers, and the ability to cancel the request. We won't use it in this basic example. Yeah, but it's required by the method signature, like you see. Okay, so the method signature requires the request and the context. Okay, let's do this. I can simply, in fact, for the sake of maybe development, okay, we can print, you can have a simple print statement saying received request for product with ID. Okay, then we can specify the request dot ID. Now on the next line, okay, we can return data. Okay, so shall return product pb2 dot product. I think it's product response. Why is it not giving me autocomplete? Okay, but let's go for it. Product response, like that. Okay, and then we can just have mock database logic, okay, for speed. You don't have to fetch from the DB, but you can do it. Okay, request.id, then The name will be something like, can say super fast laptop. Then the price 1999.99. All right, so this is just, mock database logic, but you can fetch from the DB fast, okay, before doing this. I don't want to go into the ORM specific operations because I want to focus on the actual microservice concept, okay, in this series. But if you need me to do that, please let me know in the comment section. I can edit this to make sure that we fetch from the database. Please let me know. All right, now next up, we shall create a function, okay, not a method, called serve, okay? And serve will simply help us to set up the server. So I'll say server will be equals to gRPC dot server, okay, parentheses. Then we shall say features dot thread pool executor, okay, and say max underscore workers equals to 10. I know people who have done concurrency and know it understand what is going on line 16. But simply, this tells the gRPC server to keep up to 10 workers. Okay, 10 workers should always be ready. And this means that the server will be able to process up to 10 get product requests simultaneously. Okay, if there's an 11th request, then it has to wait until one of the 10 workers finishes. As simple as that. Then I can now go to the next line of code, which will be product pb to gRPC.add product servicer.to server. Okay, and this will take in the product service. Okay, and then it will also take in the server. Okay, you must be asking, what is this? So this is simply attaches, okay, this line of code on line 17 simply attaches our logic, okay, in the product service to the underlying gRPC server infrastructure. As simple as that. Now, next thing we need to do is to say server dot add insecure port, okay, and then I'll say square brackets. I'm going to explain this in a minute. Square brackets, 2 full colons, then 1 more full colon, then we specify the port. Now, what does this mean? The square brackets, okay, what I've just highlighted right now, the square brackets with the 2 full colons is an IP version 6 networking shortcut, meaning listen to all available network interfaces, okay? Then insecure here simply means we're not using SSL or TLS encryption. And this is a standard for microservice talking, like within a secure private network, because within our container, okay, we can create a secure private network, okay, and we shall not need SSL configuration, okay, as long as we are in a private network. Even for local development, we don't need SSL or TLS encryption. Okay, then the next line of code will be server.start. I guess you can know what this is, okay? And then after that, server.wait for termination, okay? If you don't know this, it's still okay. I can explain. So the learn on line 19 simply means boot up the server in the background, okay? And this is actually a non-blocking call. It's non-blocking, which is cool. Then line 20 simply says, wait, what's happening? My editor is becoming stubborn. So line 20 is important because when server.start runs in the background, our Python script will terminate. Okay, not terminate, but exit. Okay, the right word is said is to exit. Okay, the Python script would terminate immediately. Okay, would exit immediately if line 20 was not there. So line 20 simply forces the script to stay alive and listen indefinitely. Okay, very simple. Then finally, I can now say if underscore name equals to main, I shouldn't have deleted the first code we found here. So this has to be underscores, underscore main, like that. Even here, two underscores, underscore. Then we can call the function server. So yeah, this is how simple it is. If you have any question, please let me know in the comments. Open the main.py file inside the user service. And here I'm going to modify it so that when a client requests a user's purchases, the user service will act as a client itself. And it will call the product service over gRPC to get the details. So we're going to add the gRPC imports at the top. Then at the bottom, we create the new endpoint. So I'll say import gRPC. Then after that, I will import what we generated. Remember the two files we generated. Okay, then we'll keep the existing code. Okay, I'll just minimize this. Then at the bottom, sorry, has to be outside this other function. At the bottom, I'll create a new endpoint or path operation. So this will be called get user purchase, and this will take in user underscore ID, which is an integer, and then the product underscore ID. Then I'll put the path operation decorator by saying app.get / users. Then we shall have user ID as a path param / purchases / another path param product underscore ID. I forgot to annotate product ID. It's also an integer. Okay, I think this is okay. Users, user ID, then purchases, product ID, and user ID and product ID will be given to us thanks to FastAPI. So now I want to connect to the product service via gRPC. So I'll say with gRPC.insecure channel. Okay, remember I told you we're doing insecure channel because we're going to have an internal private network with Docker. Okay, and we don't need SSL and TLS. But if you need SSL encryption, go ahead and research about it. It's not actually that hard. Then I can say product dash service. Okay, this will be the name of our service, like you're going to see very soon when we configure it in Docker. Then we mentioned the port, which was or is 50051. Okay, as channel. Okay, that's how simple it is. Then we can now create this tab and say this tab will be equals to product, okay, pb2 gRPC dot product service. Okay, this helps us to get access to our product service, but this has to be product service tab, like that. Okay, and now we can pass the channel, okay, as an argument. So think of a channel as a connection. Okay. Then we can make the synchronous call. Okay. So what I've just done, okay, using the with context, okay, and line 33 simply helps us to connect to the product service via gRPC. In fact, let me put a comment here saying connect to the product service via gRPC, gRPC, like that. Now, once we have connected, now we can create a synchronous call by saying response. We shall pick a response by saying stub dot get product. Okay. And then to get the product, we shall say product pb2 dot product. It takes in the product request. Yeah. Okay, so we are passing the request. I don't know why the autocomplete isn't picking it, but it's supposed to pass. Remember, to get a product, if I can show you in the protos, okay, to get a product, we have to pass a product request and return a product response. So that's why I'm doing this, okay? And the product request requires an ID. So I'll say ID equals to product ID. So we pass the product ID. Okay, that's looking good. And then I can go to the next line and return a response. So I'm out of that with context block and say return. Okay, we want to return the user ID. I also want to return product underscore details. This will be another dictionary, okay, or nested dictionary having the ID of the product. Then we shall have the response dot name, okay, and then we shall have the price of the product by saying response dot price. And then down here you can put another key saying source. This is from gRPC. As simple as that. So I hope this makes sense to you. If you have any question, please leave it in the comment section. I'll be very happy to explain. I will go over it so that I make sure you understand. So line 30, which I expect that maybe by now you know, is a standard GET request, okay? A standard HTTP GET route. So when a user visits the URL, FastAPI will be responsible for extracting the user ID and product ID. As simple as that. And then passes them to this getUserPassChase function. Then gRPC.insecure channel creates the actual network connection between the user service and the product service. This string, okay, instead of saying localhost, okay, uses product service as the host name. Okay, and this is because we are running a containerized service, and this is going to run in a containerized environment. So product service will map to an IP. Okay, so the network, the Docker network, will automatically route the name product service to the correct container IP address. Okay, and then using this with context, okay, which is called a context manager or a with block, is a best practice. And it ensures that the network channel is safely closed and resources are freed the moment the block of code finishes. Even if an error occurs, the block will be closed. Then the stub, okay, is simply a technical word to mean a local object which mimics the remote server. Okay, so it simply gives our Python code an object which looks exactly like the product service, even though this actual logic of the product service lives on a completely different machine. Okay, you simply pass the channel so it knows where to route the traffic. Okay, so by passing channel, it knows where to route the traffic. Then line 36, okay, this is where now we have the real magic of gRPC. So it simply calls the stub.getProduct as though it was a normal Python function. Okay, but behind the scenes, gRPC gets the product request, okay, and serializes it into a tiny binary format using the protocol buffers. Then it shoots it over the network to port 50051 and waits for a server to process it. Okay, when the server processes it, okay, then receives the binary response and deserializes it, okay, back into a Python response object. Then finally here, when we are returning the data, we are simply returning unified data, okay? And the user service simply combines its own data. In this case, we are using user ID. We add the data it fetched using gRPC. So there are two things being combined: the user service's own data and the data from gRPC. Let's create a Docker file inside the product service. So here, create a Docker file. So of course, to run everything, we need a Docker file for the product service. So I'm going to paste a standard multi-stage build. And if you missed the previous video, please watch it. Okay, I explained multi-stage builds in detail. And this has the same logic, apart from a few things that I've added to teach you a little more about Docker and UV. And those lines actually not many. The first one I can show you is at the top. Okay, actually the first two, yeah, these two simply are responsible for giving configuration to UV. So the first one, called UV compile bytecode equals to 1, simply tells UV to precompile Python into .pyc files, okay, and speeds up our gRPC server startup time. Then UV link mode equals to copy simply tells UV to copy packages into the virtual environment instead of hard linking them. Okay, yeah, just for now, let's try it out. In case there's an issue with this file, I will edit it. Then of course, on line 16 and 17, okay, I'm just copying the virtual environment and the services directory separately, okay? But it's actually the same thing, okay? We'd copy everything like we did for the user service, but just to show you a variation, okay? Yeah, so if everything is okay, I will just edit, okay, in case we run into issues. Okay, then line 21 is simply telling Python to find our imports, okay, in case it's looking for an imported module, okay. It should check inside the product service folder. Okay, so it will allow Python to cleanly find the generated gRPC files without us having to mercilessly alter the path inside our code. Okay, yeah. So I think this is it. And of course, this other line tells the container to boot up the gRPC server when the container starts. If you have any question about this Docker file, please let me know. I'm going to push it to GitHub. And I think we need one more thing. I'll close this. Let's go to our compose.yaml file and add a service. So we have the user service, we have the database. Okay. So just below here, you can add another service. You can call it the product. Actually, yeah, just I wanted to put it below the user service, but it's okay. Let me just put it here. User service. Okay. And then for this one, I'll hit tab and say the build. Okay. Full colon, next line. Context. In this case, will be the current working directory. That's where it will find the compose.yaml file. And then the Docker file we're interested in is in services / product service / Docker file. Okay. And then here we don't need ports to be exposed. Why? Because you're going to have internal communication only. Isn't that nice? Yeah. So next up, let us try to run. Okay. Let's try to run. I'll clear my terminal. Okay. Expand a little bit. Then run docker compose app -- build and wish me luck. So it's going to take some time. I will be patient and wait. So like expected, there's an issue. Says downloading gRPC tools, failed to download typing extensions, failed to extract archive, saying typing extensions was included because product service depends on gRPC, which depends on typing extensions. All right, let me resolve this and then get back to you. So when I looked at the stack trace, I saw it was a timeout error. So I increased the timeout. Look at line 4. It says UV HTTP timeout. I increased it to 120 from the default. Then also here I did the same thing. So you can add that. Okay? Increase it the more in case your network is really, really slow. And of course, now we had success. So let me try docker compose app. Okay, look at this. Looks like everything is okay. I'll go to the browser. Let's type localhost. Localhost, it's port 8000. First of all, if you look at the docs, wait, why did it say it cannot be reached? Localhost, Control 0, localhost 8000, 8001. Okay. All right. This gives me hope. I was starting to get worried. Okay. So I can expand this and click try it out. Put user ID 1, purchase, product 99, execute. I'll make this bigger. Okay. All right. I see that we have some good result. Says user ID 1, product details, ID, name, price, and the source. Yeah, this is nice. Actually, let me just copy it and paste it in the browser. Open a new tab, paste and hit. Okay, expand, pretty print. Yeah. Okay. We have 2 services. Yeah, it's been nice. I'm enjoying this. Okay. Yeah. So behind the scenes, our user service fires that binary gRPC request to the product service, fetches the laptop data and returns it to us as JSON. It works flawlessly. Okay, so now we have 2 services, but of course, like you see, exposing them on different ports is messy. In day 6, we are going to introduce the API gateway. All right, so yeah, subscribe, and I'll see you there when we have a single entry point.